Now that we've spent time looking at what the chain rule does for algebra, what the chain rule does generically, we want to look at what happens with the chain rule in respect to trig. So I have my 6 trig derivatives on the screen in front of you. They should look very familiar. You should know that the derivative of sine is cosine. You should know the derivative of cosine is negative sine. You should know the derivative of tangent, secant, cosecant, cotangent. So all of these are not necessarily new. But what I want you to notice is now we're looking at what happens when it's a sine of some random angle. So we're using the letter u to represent a function of x. So now we're not talking this derivative of the sine of x. It could be the sine of 3x or the sine of 10x squared or the sine of 2x plus 5. So we're really changing that angle, and that becomes a composite function and relies on the chain rule. So all of these you should notice look very, very similar to the derivatives you know, but just that added piece. And you'll notice with every derivative, we have this du at the end. That du is just asking you to derive the angle. So that's like whatever that angle is, that's that du piece. So you're deriving your trig function with a rule that you already know, and then you're multiplying by the derivative of the angle. So when we're doing chain rule with trig, there's actually 3 types of problems. And I like to kind of break it up into type 1, type 2, type 3, so you can kind of see what makes them different. So this video, I'm going to show you the first 2 types, and then I'm going to do the third type in its own video because it's kind of a combining of the 2, and it is the longest of the 3 types. So with type 1 trig chain rule, you're going to be looking at a trig function that has an angle that is something other than x. You're going to have just a single trig function, so it's just going to be sine or cosine, one of the 6 that's up above, but the angle is going to be different. So the reason that I wrote 2 factors, what that means is your answer when you derive will have 2 things being multiplied. It's going to have the derivative of the trig. I'm going to write that down. We're going to derive the trig, and we're going to derive the angle. I'm going to put theta for an angle. To be honest, I usually do the angle derivative first because I like to put it in the front. So with this one right here, the derivative of the angle, the derivative of 7x squared is 14x, and the derivative of sine is cosine. The angle will not change in that trig function. So when I derive sine, I get cosine, but the angle that was 7x squared remains 7x squared. And you'll notice that from your work up here. Whatever that angle started as, it can't change. We don't have the power to change angles. So let me show you a few more of type 1. So again, we have a cosine, but the angle is 6x. So the derivative of 6x is 6. The derivative of cosine is negative sine. So I'm just going to put the negative in front. For the one on the top right, the derivative of the angle is 5. That's the derivative of 5x plus 3. And then the derivative of secant is secant times tangent. So secant of 5x plus 3. It's probably the biggest thing to remember, especially when you're like typing things into Delta Math. Make sure you put your angle back to whatever it started was. It's kind of easy to start forgetting that and just writing x's everywhere. For the third one on the bottom left, you'll notice this has the trig right here, but it also has an x squared in the front. What this means is you, in addition to knowing your trig derivatives, you also have to do a product rule here. So it's kind of, again, a combining of rules. So with my product rule, and the reason I have to do a product rule is because they are currently being multiplied. It's first times the derivative of the second. The derivative of sine of 2x, derivative of the angle is 2, derivative of sine is cosine. So it'll be 2 cosine 2x. Plus second times the derivative of the first. I'm actually going to put the derivative of the first in the front, just because I like my x part to be in front of my trig. And that's it. You'll notice the difference when you do product rules and chain rules with trig, there tends to be less algebra and simplifying than the ones that we did that had algebra where you could do exponent rules and distributing. You don't really have that with the trig ones, so they tend to go faster. And now this last one is a quotient rule in addition to being trig because you have the division. So your quotient rule is the bottom times the derivative of the top. The derivative of tangent of 3x is going to be 3 secant squared 3x minus the top times the derivative of the bottom. Well, the derivative of the bottom is just 1, so it's just going to be minus tangent 3x all over the bottom squared. So these are type 1 trig problems, some just basic trig and some that have another rule combined with it. Type 2 may be one of the shorter things that you do here. Type 2 is when the trig function is being taken to a power. So you're going to have a sine of x or a cosine of x, but instead of being to the first power, it's going to be squared or cubed or taken to the 1/2 power. It can be fraction power, it can be whole number powers. This one, you're going to get 3 factors to your answer. And the best way to describe this is going to feel the most like your regular power rule or your regular chain rule with powers. So the way that we do this, and does help to remember your notation. When I put the little 4 right here, what I'm actually saying is that entire sign is being taken to the 4th. So your derivative is going to be power out front, power 1 less. So now it's cubed, and you can put it in parentheses and put the cubed outside, or you can write it like that. And then times the derivative of what's inside. And this time what's inside is a trig function. So the derivative of sine is cosine. So with these type 2, you're going to do your power out front. Just going to write power out. You're going to do your power 1 less of your original trig function, and then you're going to derive the inside trig function. It's going to be your kind of 3 factors of your answer. So for the second one, power comes out front. Cosine is going to drop to a power 1 less, so now it's just to the first power. And then the derivative of cosine is negative sine. And if you want, you can bring that negative all the way to the front, so it doesn't look strange having a negative partway through your answer. Or you can keep it in parentheses and keep the negative with the sign. For the next one, same idea. Power comes out front. You're going to drop it to a power 1 less, so it's going to be secant squared. And then the derivative of the inside, the derivative of secant, is secant tangent. So you're going to have a secant and a tangent. And probably on the AP test, they're going to put these secants together. They're both secants. One of them's to the second power, one of them's to the first power. So more than likely, you're going to see it written as 3 secant cubed times tangent. They do tend to do basic simplifying when possible. If it is under a radical, or if it's in the bottom and you want to rewrite it, it's going to make it much easier to start the process. So when you see a square root or a cube root, you're going to use fractional exponents and then continue with your power rule. So power out front, power 1 less is going to drop it to the negative 1/2 power. And then the derivative of tangent is secant squared. You do want to get in the habit of getting rid of a negative exponent. So I'm going to write my final answer as secant squared x over 2 times, you can either put tangent in parentheses and do the 1/2, or you can put a square root tangent of x in the denominator. And that is type 1 and type 2 of how to deal with trig chain rule. I'll do the last video with type 3.